Hello and welcome to today's SEI webcast, From Chaos to Clarity, Conceptual Modeling for Complex Systems. My name is Shane McGraw. I'm the Outreach Team Lead here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make today's webcast as interactive as possible, so we will address as many questions as we can. You can submit your questions in the YouTube chat area now, and as I mentioned, we will get to as many as we can. We also had a number of questions submitted prior to the webcast that we would like to get to as well. Now I'd like to introduce our featured speakers for today. Hasan Yasar is the Technical Director of the Continuous Deployment of Capability Directorate here at the SEI. He leads an engineering group that develops prototype solutions with DevSecOps. Hasan, welcome. Glad to have you here today.
Thank you so much, Shane. I'm really honored to be part of such a distinguished speakers and looking forward to have a great session with all of you.
Thank you. Next, we have Dr. Wolfgang Maass, and Wolfgang is a distinguished professor at Saarland University, specializing in business informatics and computer science. He also serves as a senior data science advisor at the National Cancer Institute in the United States. Wolfgang, thanks for joining us today.
Shane, thank you very much. Thank you for having me.
And last but not least, we have Hyoil Han. And Hyoil has been an associate professor of computer science in the School of Information Technology at Illinois State University since the fall of 2016. Hyoil, great to be here. Thank you for thanks for joining us today.
Thank you for inviting me. I'm excited about this talk. Thank you.
Terrific. Now for our opening remarks, I'm going to turn it over to Wolfgang. Wolfgang, all yours.
Shane, thank you very much. It is my turn to say a few words about the context of this webinar. And as you might see with the slide that I put up here, that conceptual modeling is at the heart of our discussion, and it's also showing the questions that you send in that conceptual modeling is not dead. Yeah, you might think that with artificial intelligence, agile programming, and all these kind of new methods that you don't need conceptual modeling anymore. But as we might see in the discussion, conceptual modeling is more alive than ever. So what is conceptual modeling about? I mean, in the end, we want to abstract from reality to find models that are good representations for a particular domain. The interest of the research that I am conducting together with my group at the German Research Center for Artificial Intelligence is in particular the relationship between conceptual modeling and AI. AI, if you look at AI, the big systems like ChatGPT, Gemini, but also mid-sized systems, they are more or less black boxes. And decision-making is very difficult if you look into AI. So the question is whether conceptual modeling as a knowledge lens on systems is helping to design AI-based systems, but also on the other hand side, whether conceptual modeling is also a means for explaining artificial intelligence systems. This is called here and denominated here with loop number 2. You see down there buzzwords and keywords that are driving a lot of research, not only in my group and Hasan's group and Hyoil's group, but worldwide about trustworthy AI, explainable AI, ethical AI. And when it comes to system design, you see all the items below loop number 2 that are also very important and current research interest. But where do conceptual models come from? And this brings us more to the left-hand side. And when I look into the questions for this webinar, I saw several questions that are more related on the left-hand side, namely the side where business and groups and individuals are working together before they can actually design a model that can be used for implementing systems. In the middle, you see mental models that is related to what individuals have on their mind when they think about systems. And these mental representations are what drives an engineer's work, and also designers' work, and programmers' work, but also business people's work. And they are, this is indicated here by loop number 1, anchored in the business perspective, in business objectives, budget and resource constraints, risk management, market and regulatory requirements. And this needs to feed into what the individual thinks. And but because nowadays complex systems are never individual work, they are group work. So conceptual modeling and in general is also doing research and also practical implementations about the shared understanding of these mental models. So I want to get across what my understanding of the system is. And if you are coming from different departments with different cultures, you know the complexities. Before then, with the yellow arrows that you see in the middle, you can translate that understanding, individual and shared understanding, into something that is socially constructed. And then related, if we talk about AI-based systems, into something that is algorithmically constructed. So this is, in a very brief nutshell, very short nutshell, the whole domain of conceptual modeling, plus the implications for artificial intelligence. And now I hope that Hasan and Hyoil will also support me and give some additional thoughts, because it was probably limited.
So I may chime in here, Wolfgang. It's actually great to start as the mental models. It's really important for a business perspective, or understanding what the business needs. That's actually common questions, common understanding, almost every domain. Yes, we are talking about the complex systems. Maybe I should open up a little bit of what the complex system means. And complex system is not a typical one business logic from end to end. That might be many entities in it. That might be many business components in an organizations or a systems. Think about the cyber physical systems, and think about as the water control systems, think about as aircrafts, or any type of devices that has human and as well as the machine interacting each others. So to understand that domain, it's really requiring to represent domain as each of entities. And that's the kind of a conceptual modeling will help understand the business needs, objectives, or understanding of the components, so we can visualize those components, how they're interacting each others. There's no way like a one elements, one model we can present it. We should have a multiple layers, and I'm sure Hyoil can chime in here as well for a multiple layer aspect of it. But at least we need to think about more, what is this we are trying to achieve? What our outcomes are? That will derive the construction phase. And I have been seeing in my experience, a lot of folks and organizations are diving into the construction phase immediately, which is we like to get something done quickly, but we kind of miss the opportunities to understand what the systems that we are trying to build. So the business loop 1 is literally definitely will explain where we are in this space, where we are in the complex systems, what interaction each of the components. And at this, we have a shared understanding. That's a really key point as an outcome. We will give about the shared understanding across all the stakeholders. It doesn't mean like a one person. It is about the organization and knowledge. People understand what things we are trying to make it. And other things actually added here, I really, really like that about the budget and resources. And I saw so many examples so far. We are building up a very difficult, very subcomponents, very complex systems, but we're not able to execute literally who's going to do what. That might be some entities are depend on each other's. Entities can be one of the components in the complex systems in cyber physical. So maybe they're depend on each other. Can we run as a parallel to build it? Can we have sequentially like phases approach? Which one we're going to follow it? people are really struggling to allocate enough resources and budget resources about infrastructures. Resources can be a human, resources can be individual third-party companies, and also as well as the budget. There is no infinite time and budget for everything. What are the relationships are? So this mindset as building up a mental model representation that will help for a budgetary perspective and resource perspective.
Yeah, so this I saw the loop too, and it shows the conceptualization. So how can it can be connected with the AI-based systems? So with AI ML models, so hierarchically designing the conceptual modeling, we can design complex systems. So I think it shows very simplified version how we can incorporate conceptual models into complicated AI-based systems. Thank you for the good slide.
I guess we can start the questions and then try to get more interactive as well, because we would like to get us dive into the more interactive sessions and get the attendees participation too.
Yeah, first, Hasan, I just like to always shout out our audience. We just get such a great crowd to these, and we're so appreciative. I see people in the chat from Germany, Mexico, Uruguay, Romania, North Carolina, Seattle, Kansas, Philadelphia. So we're just appreciative and really enjoy seeing such a worldwide audience join us here today. So as I mentioned at the start, we did get a number of questions prior to the webcast when we released registration. So we want to start with one from Vanessa. And Hasan, we'll pose it to you, and if you want to pass it on to Wolfgang or Hyoil, that is fine as well. But Vanessa asks, in what ways does conceptual modeling differ or relate to model-based engineering?
That's actually the very interesting question to tackle it. So when we look at a conception model, it's all related to each other. So like we have to understand the business first. We have to visualize, we have to understand where are we in this space. That's maybe the first phase we can think about the conceptual. Like, do we have understanding, a mutual understanding let's say we are building up a product, what the product we are trying to build up. Do we have a common understanding about that product that we know about it? Then we can try to describe the attributes and components of that product or system that we are building that will come up more implementation infrastructure or construction phase. So we should really think about as early as what we are trying to do, understanding domain, understanding the business needs, understanding outcomes, understand the value. That's going to give us a first start of work. You may call it the requirements engineering, we do, but sometimes requirements very solid definition we are writing. But before writing requirements, do we have a clear understand what we are trying to build it? Sometimes we may call it a domain-driven design, understand the domain, but let's understand who we are as an organization we do, what the products we are trying to build it. Now we can get into the more construction phases. That's with MBSE and model-based system engineering we'll talk about. Hyoil and Wolfgang, anybody wants to chime in, please?
Yeah, I mean, conceptual modeling and model-based engineering are overlapping concepts to a certain degree. While exactly as I fully agree with what Hasan said, that conceptual modeling is more on abstracting representations of systems and domains to get an idea about the logic of the system that shall be designed and implemented. So conceptual modeling looks at key entities and relationships and constraints to understand, communicate, and define requirements on a rather high level, while model-based engineering is coming more from the formalization side. It's more formal systems that can even be used for simulation and automatic code development. So I think they are working on different levels. Logically, you start with conceptual modeling in order to get an abstract view on all this, and then you move on if you want with model-based engineering.
All right, thank you for that one. The next one we got, and we're going to stick with you for this one, Wolfgang, if okay, because you kind of touched on this at the start, but from Greenfield had asked, what are the key facets of conceptual modeling? And again, we got people joining us at different times, so if you can recap that for us.
So the key elements of, I mean, conceptual modeling is a broad term. I mean, when Peter Chan brought that up in the 70s, middle of the 70s, it had a very concise meaning, and now we have different flavors of that. But in order to recap what the original idea was, it came from a more philosophical perspective, yeah, that you say it's an ontological separation of things, of complex systems in the end. And coming from this philosophical tradition, it became clear that we need to talk about entities, and which are could be very abstract, yeah, it could be very tangible, yeah, but entities in the sense of objects, and on the other hand side, on relationships between these entities. And it turned out that this was a very powerful and very clear-cut idea. And what made it very appealing for database systems was that you could attach attributes like the features that you have in database designs, or this was very helpful for designing relational databases, and this went hand in hand also with knowledge-based systems. So the idea of entity relationship, attributes, cardinalities, and later on also constraints, these are the key elements of any conceptual model, in particular entity relationship modelings.
Anybody want to add anything?
Yeah, the relationship. Oh yeah. Oh yeah.
I'll go first.
Oh yeah. So the entity and relationships and then constraints, they are important in entity relationship model, but also in the more broad way. We can consider when we do conceptual modeling, we need the structure and operation and constraints. So it's a little bit more broad way. So conceptual modeling, with these components, we can apply to any complex systems. Yeah.
If I may chime in here a little bit,
yeah, go ahead, Yep.
Connecting our current needs. So every organization, they are using different way to express their understanding about their products. So what I was saying it as conception modeling, as specific notations and key facet, it's going to develop a common language, common understanding. When I say common language, common communication, doesn't matter which language we use, talking, which type of kind of description we have. It's going to give us a visual representation that goes back to the Wolfgang slide and look to give us a visualization of the work for a specific product. We all have a mutual understanding. This is actually a key point we should remind ourselves. Do we have a clear understanding? What are we trying to build up? Do we have again, doesn't mean one graph, we may have a multiple, like usually when we look at the network layer architecture as an example, we have multiple layer of network graphics. Basically, we have the layer 1, layer 2, we have different layer of representation of network layers. Depends on how much we can go to lower level, from higher level, lower level. The similar things, we should think about our business and product level. What are the layers we have? So it's another thing's gonna build up a knowledge of our system that we are trying to build up. If we don't have it, again, a little bit think about negativity perspective. If you don't have that common understandings, what will happen? People, if they don't have an understandings, they do some assumptions. They will say, oh, that means if they cannot find a person who design or an organizations, they're gonna make some assumptions. And usually they're gonna look at the architect of the code pieces and try to understand what it is. They're gonna look at the code commands or have something else. People are looking for some visual representations of the work. And I believe the conception model will give us a visual representation of what the product it is. Then we can go references, we can share amongst other stakeholders. That's really a key point to grasp as use it. Otherwise, it is going to become a person's head. And then what is happening with this current situation, there is no way one person will visualize everything in their head. It's impossible. That's what we are seeing a lot of interest on many people all around the world. we are living in a very complex world. We are living in very dependent systems right now. All are dependent on each other. There is no way a single person or an organization will have everything. But there is a way to document of the systems and store it and share it, and we can learn as an organization. That's kind of, I look at the key facet as sharing, building up a common understanding about the model that we are presenting.
Can I add something, Shane?
Yes, please do.
I like very much what Hasan and Hyoil said. I mean, I'm at the university, and when I teach to young people, it is not easy to get across the idea of modeling in general. So I perceive conceptual modeling also as a mind shift, yeah, as something that you have to learn first. And what we try to tell young people, but also people from other domains, yeah, if they come from marketing or finance, yeah, they don't have that kind of concept as we have. So it's a kind of thinking how to solve problems. And for those people who know about anti-relationship models and conceptual modelings and BPMR and BPMN and all these kind of languages, they say it's boring, it's easy, it's natural how to do that. But for everybody else, it is a learning curve. But the level that conceptual modeling is working is, it is not mathematical formal, well, which excludes 90%, 99% of all people working in a certain project. But it's also not fuzzy so that everybody can interpret everything. So it is a certain level of specificity that you say, okay, now I understand to a certain high degree what we are actually talking about. And this is what Hasan said about shared understanding, yeah, to really find this kind of level. And their conceptual modeling is helping a lot.
Great, thank you for that. Next, we're moving on. We're going to pose this one to Hyoil. Orlando had asked, is entity relationship, ER modeling, the only means to leverage conceptual modeling, or are there other approaches that could be used for the same purpose? Hyoil?
So the other than ER model, whether other way to do conceptual modeling is the question.
Yes.
Okay. So ER modeling method is one way to do conceptual modeling, but for conceptual modeling, we can use other modeling language or just like famous UML and other ways we can use. So so not only ER, but also UML. And I think it's, yeah, I think those two things are most famous and widely used one. Yeah, so either way is fine, but UML, it has more way to specify the system. So you can build, if you have a very complicated software system, UML has many different ways to express the situation. So you can use UML to do that.
Hasan or Wolfgang, anything to add there?
Yeah, I can start while getting the Wolfgang in the lineup. And that goes back to the representations of the business understanding. Depends on where we are in the solution of the product. When we say solution of like describing what the product, we can start one as understanding what the product is. You may use PowerPoint, you may use some other representations or other drawing. Now, once you get to the more specificity of the product description or a component description, we can start to use different modeling. It can be basically UML, it can be context flow, it can be SysML, it can be MBSE. We can start to go more specificity on the construction level for each of the entities. So, and then we can think about the relationship each other. That's actually to connect the dot in between each of the components. So I will say, don't really stick in the one representation. Depends on where you are in the product life cycle. You can use those representations of what you would like to achieve after modeling. Remember, model should be clear to explain what it is, what we are trying to do, should able to share the key elements about describing relationship, attributes and components and other relationship interfaces. So that's basically depends on where we are in the product life cycle that I can add it.
Yeah, maybe I can add, I mean, you can always go up the abstraction ladder towards more informal and more formal representation languages. For instance, if you want to have a more formal representation, you go into formal concept analysis, FCA, or Petri nets, if you have dynamic systems. Or if you look into data flows, you go data flow diagrams, a very simple way how to model data and data flows. Yeah, so there is very many ways how to additionally model depending on where you are with respect to your engineering task or process.
Great, thank you for that. I'm going to get to one live in the chat from Roy. Asked a good question. How do you assure that the system, when deployed, is reliable? So Hasan, we're going to start with you on that one.
With respect to
Thank you. It's really interesting questions, actually. Kind of.
I'm going to get to one live in the chat from Roy. Asked a good question. How do you assure that the system, when deployed, is reliable? Yeah, we just need to mute the sound. There we go. All right, Hasan, back to you.
So it's really important to get the understanding about outcome. So that's actually very important to make sure that our system is safe and reliable. So its reliability also represented safety. It's very important. System is expecting what's supposed to do. So which goes back to the overall beginning. And usually, if you don't have a clear understanding about our constraints, our product that we are building, our entities that we have, then we may not able to represent those entities, attributes throughout the product life cycle. We go at the end. I'm going to bring my DevOps head here a little bit. In DevOps perspective, we always say, fail fast, learn fast. But we don't want to fail fast at the production level. That's what exactly Roy is asking. We don't want to fail at the production. We cannot take a risk of failing a car as automatically updated over the air while I was driving. We don't want to accept those failures because safety comes as an important factor. We will let the fail fast early in the life cycle. How do you do the fail fast early in the life cycle? That we need to know our constraints, our requirements, our business domain. Try to build up the test cases and infrastructure. That goes back to the Loop 2 slide on the Wolfgang, and he talked about the construction phase. So we think about all the possible scenarios with our requirements understanding, try to plan those early in life cycle. We can eliminate any issues in the systems running in an environment. And other things I would like to bring in here as well for specific systems deployments. Let's try to test those entities and units before it goes into the production and be ready if something happens. That goes back to then again analysis. What are the failover scenarios looks like that we need to address those failure in the production with our best? We have to. But some cases we may not able to see everything. It's a very difficult and challenging situation. If you cannot see everything and upfront, which is not possible, so we have to put other measurement, other controls in our safety critical system, put a failover scenarios case by case, and then plan those potential outage, which is basically a chaos concept. Do some analysis, what if something goes wrong in a production environment for such as systems? How can address those potential things by adding an architectural or entities or a component in advance and eliminate those failures? Well, I can talk a lot, but I'm just going to stop here, give a little bit of time for everybody, because I gave a talk yesterday, actually, on a similar topic about chaos engineering, so in a cybersecurity domain.
Very good. We're going to move on one for Wolfgang here from Gladys asking, how do we teach students or anyone who are typically educated in a single domain to model real-world complex systems that span domains?
Yo,
Feel free to pass, Wolf Han, if it's not you.
Uh, when I teach, actually, because in the school, in the course, we can have a big project like that spans many domains. So when we do requirement analysis to build a conceptual modeling, I try to introduce several different ways to design, and then if it's a different domain, how it will be different. So those things I introduce as much as possible, so the student can have open domain thinking. And also when they actually do conceptual design, because design can be very many choices for the same thing. So, and when students have different choices, I discuss with the students why they chose that direction, and then how that direction will give the result, which impact on the result, so that they have they can learn many different possible ways or possible results from one choice, so that student can see more than just one domain or just one way to solve a problem. Yeah, I'm doing that way. Yeah.
I mean, I can say a few words, even though that I come from a different angle. My students I work with are coming from computer science and especially AI and machine learning. And my task is to convince them that conceptual modeling adds value. And because they think you only get data and then you train a model and everything is fine. And this changes, the whole discussion changes when they realize that the system becomes more complex and that the AI part needs to embed it into a larger system. And if you then talk about microservices and different databases and data lakes and so on, out of a sudden, the question comes up, how can we model that? Yeah, and then we start slowly entering the domain of conceptual modeling, while cross-domain, this is typically beyond what I'm doing. So there, Hyoil is better off.
Here's what I do at my CMU graduate students when I try to explain the business understanding and value. That actually interesting when I connect my, again, DevOps head. People are using as fast and quick. Yes, we're going to get result, because sometimes you cannot visualize, like you cannot think about as an objectives and goals. It's just still abstract. But the students, you would like to see quickly, build something quickly, show it. Is that what you mean? I see a lot of iterations becoming a bring me a rock situation. I said, like, every time, step back and ask yourself, what are you trying to do? There's always an understanding. It's a boring task at the requirements. Everybody is in engineering community, software engineering. They will like to write code every time and build up something. But we need to understand what the user needs. There are a lot of failure organizations. They're not able to meet the user needs. We can build up something. If we don't understand what the user means, what the user is asking, there's a failure. So the people like using, hey, I'm going to use agile practices, and agile practice will tell me I can do everything what I want. But hold on, there is actually a process in agile practice. They say there has to be a value for the users. That has to be value from a user's perspective as we're delivering a product. So I kind of explain to students, if you don't understand what the outcome it is, it doesn't matter how you solve it. You're going to solve based on understanding outcome and try to understand, explain what is the outcome, what is your goal it is. It's about the mental model, which basically they will get it after a couple of failures. And then they will learn by failing a few times. They say, oh, I should have spent more time to understand. That's kind of they show an example. Look, you failed it, and you should think about it a little bit more, understand it. You know, and other things, I give an example, said you're using a lot of gadgets in your daily life. And you just assuming everything is going to work. If you're not able to post something in a matter of minutes, you're getting upset because you say internet is not working, this is not stuff. That's basically the value. It's over there. If as a user, if you're not able to use that tools and social media, whatever you have, then you're going to be unhappy. That's exactly what I'm trying to explain. If you're not happy, that means what you're building, if it's not hitting the target, your customers are not going to be happy. So that kind of analogy I try to use to explain, to understand what the requirement, what the modeling it is.
So we had a good comment from Mel, which I'll read off. We can get a quick response to. Mel says, yes, conceptual modeling is common and quote unquote boring in software engineering. However, most of our requirements come from the business.
Yeah.
Are there conceptual modeling techniques that bridge the non-technical folks with the engineers and developers?
It's honest, it's very well said. What we are trying to explain, if you don't able to explain clearly with engineers, it is going to be a solution not going to be used clearly with everybody else. I concur with that statement.
Yeah, and I think there is a very deep thoughts behind that, because we try to translate business ideas into something technical. And what we are doing is we do it step by step by translating from one language into another language. And the goal is not to lose too much semantics, so that the people from the business side, yeah, they can follow what that means on the technical side. And then the translation goes back. And if this translation over all these languages that we are using, yeah, at the beginning you have workshops and you have whiteboard scribbles somewhere, and then you translate that into some rough specifications, and then you go into detailed conceptual models, and then you have logical representation, you have physical representations, and then you have implementations in the end. And all these are language translations with the goal to keep the semantics, so that all agree that this is a product we are targeting at. And this is a very complex task requiring a lot of communication, and what the goal in computer science is to support that with tools.
Okay, thank you for that. Next, Joe asks, and we're going to stick with you on Wolfgang, just at least to start with this one. What are the dominant products in this space, and how are they adapting with generative AI?
Products in what regard?
The dominant, I guess, in terms to conceptual model, what are the dominant products in this space, and how are they adapting with generative AI? Is there any specific generative AI tools maybe you're using to teach in your class now, some of the concepts of conceptual modeling?
I mean, on the conceptual modeling side, there is a plethora of tools that you can use. I mean, you can start very simple with PowerPoint and scribbles. There are many, and I don't want to mention particular software companies, as I was advised. Yeah, that this. I think you can look up how to do the conceptual modeling and notations. But on the other hand side, integrating that with generative AI is a very interesting question, because that is actually unsolved at the moment. We are doing a lot of experiments. I mean, if you're using generative AI for developing conceptual models at the moment, it doesn't work well. Yeah. Why doesn't it work well? To our experience, it doesn't work well because the input that you need in order to inform the system what is the context in which you want to develop a conceptual model is quite extensive and exceeds usually the input vector size of generative AI models. It might change with state-based systems that we are investigating currently, as they were developed at CMU actually. But these might change. But at the moment, I mean, it's just supporting if you want to do some modeling. So the integration of conceptual modeling and AI is currently looking mainly into explainable AI, trustworthy AI, transparent AI. These are the words that are currently driving research. And I don't see that it's currently used in practice beyond GitHub, Copilot, or stuff like that.
Hyoil or Hasan, anything to add to that?
Actually, I do not use generative AI for conceptual modeling as of now, but because the conceptual modeling is actually abstracting. We are abstracting the real world situation into modeling. So using generative AI, it will be a little bit complicated, but someday maybe we will see. Someday maybe it's possible, but not now.
I will add a few thoughts here as well, if I may, Shane and team.
Yeah.
And when I look at the Gen AI, it's kind of a, Wolfgang touched a little bit as well. It's going to be more assisted, what we are trying to do. But at the end of the day, it goes back to the explaining the domain and context is really matters using any Gen AI tools. What the contexts are, if you don't have a clear understanding of our business, if you're not able to describe what the business, what the things we are trying to solve, Gen AI will probably generate something may not be relevant to us. Let's define what the understandings are about systems. Actually, there's a growing the concept in the community. We think about a system level thinking or systematic thinking, which is it's more understanding the product and systems. We can define it as a domain. I know there is a couple of questions about domain-driven design too. If I don't have an understanding domain, and asking about AI may not help us a lot. We have to be clearly describe what is our business constraints are. Then use as the generating the diagrams, it will help if you define very well. So there was a question about the tooling. There are many tools available, even though if we are looking for a human intensive work that we're going to generate it, probably Gen AI help us on those type of human effort required context creations. But as a human, we have to explain what the domain we are in. That's basically the understanding about the domain. So we need to think about a little bit careful to describe what are we trying to solve and take an advantage of any Gen AI to help us. Again, I'm not expert in Gen AI. I'm just using as the what things is going to help my job to get the job done specifically of the domain expertise that I would like to do.
Okay, so we're going to stay with another one for you. Bruce had asked, it's a little longer here. I remember system modeling in general and ER models in particular being all the rage in the 90s, in the 1980s and 90s before falling out of favor. What's new? That would be the impetus for the revival of approaches like this. So Hasan, we'll start with you on that one.
Yes, I know you're going to touch on the Shane this one. Which we kind of a little bit touch on the Wolfgang and he was talking about too. It's basically a boring task. Goes back to one of the commentator actually put the notes in the YouTube. Yes, it's a boring task, it seems, because we are in a very fast-paced organization. We're going to go fast, and quick. We ignore the understanding of the system. It looks like we are 1980s and old days. Still the same mindset we should be thinking about it. Things is moving so fast. We have so many components. We have so many code is produced. If you ask me like 30 years ago, I was able to write everything from scratch. And I was the C++ programmer. I used a lot of assembly language. I was literally writing everything from scratch. I know every piece of component. But right now, there's no way I can know everything. It's impossible. But the things didn't change. Like still we have the phases of life cycle we use all the time. But we use in very modular, very specific components. So we don't drop the software engineering principles at all. Still we are using it. But we are using those principles very fast. Sometimes we do shortcut on the requirements. Maybe we just go grab one of the container images and use it. Sometimes we basically do open source tools is already done. We're just going to glue together and build it. But still, we are following the core engineering principles. So even though we are saying it's like 1980s thinking, I completely disagree. It's becoming more important now ever before because we have so many systems is getting together. Like, and then there was an outage I don't want to label specifically, and people were struggling why this happened. Affected millions of computers in the world. All of us got affected somehow. It's an example of that understanding the system complexity. That goes back to the old days we do. Now let's keep remembering. Let's think about step back and understand end-to-end business flow. That's what the conceptual modeling is telling. That's what is happening. So what is not happening, as right now, we should think about it. I'm sure Wolfgang can chime in with kind of a little bit discussed at the past, kind of a couple hours before. It's about the dynamic creation of the model. So it's about more static. We are trying to understand end-to-end flow. How are we address the dynamic creations of changing the model itself? That is the new pieces. Maybe Wolfgang, you can chime in as well for dynamic creations and modeling that we discussed.
Yeah, I mean, in the conceptual modeling community, in the last 20, 30 years, we have looked at database systems that have quite static data schema, yeah, and they persist even longer than the systems they are built on top, yeah, so very persistent kind of structures. And now we are getting more and more, and that already started with these more dynamic database systems that are used in social media, where you change the schema quite quickly. Yeah, that was not possible with relational systems. And now we also have systems that can learn over time and very, very rapidly. And the question is whether we can model that kind of behavior and whether we can check that kind of behavior. So what I mean is we need to find ways from systems, system theory, learning from system theory how to integrate dynamics into conceptual modeling. I mean, in process modeling, you always had some kind of basic idea like Petri nets on dynamics. But I think there is more to come in this complex, but at the same time, very dynamic kind of systems. And what is additionally very important also for our work and where conceptual modeling can help is everything related to data-driven decision-making and big data. Modeling which kind of data do I actually want to use, what is the quality of the data, what are the requirements of the data, how do features relate to each other. Knowledge graphs is now all over the place. Yeah, that is a better structure in certain domains for training models like graph neural networks and other kind of networks. But then the question is, what is the data telling me? What is the semantics of the data? Where is the data coming from? So there is an abundance of new questions that require better understanding and conceptual modeling.
Great answers. Thank you for that. So we got about 12 minutes left, and I know you guys have an event coming up at the end of the month, hosted on the campus of Carnegie Mellon University, ER24. So I wanted to give you guys a little chance to plug that event and what type of attendees are you looking for, and what are people going to learn. So let's start with you, Hasan, on that one.
Thank you, Shane. So we are hosting a ER 2024 in October 28th and until October 31st. I know it's just a Halloween that we have October 31st in US, which is another complexity I'm going to tie it here as well. So what we are expecting it's a research conference, and it's about the conception modeling and relationship with AI as well, about the data ontologies and really talking about different topics too. But mainly what we are trying to achieve to explore what are the new research areas in that space. We have great researchers that all around the world, and our acceptance is really below 20%. And I'm really, really honored and be happy to have a great contribution from research community to exploring what are the potentials or what are the current issues that we need to address under the conceptual modeling, AI, related to the data taxonomy as well. So attendees will learn when they attend. I'm hoping that we can see more people. They will learn what is really happening in that space, what are the cutting edge research are in that space. And also it is great to have a collaboration and discussion with the researchers. Sometimes we always thinking we kind of do best knowledge what we have, but sometimes we need to get together and discuss. This is an opportunity, let the people and community and discuss and find out or get together or explore different ideas, to exchange ideas for better for the community, for software engineering community that we're expecting. So we have multiple tracks, we have tutorials, we have workshops, and we have a fully loaded schedule actually. And we're looking for a kind of a that was actually interesting. In our scheduling, we said how much we can give a time to people they can talk. We have so much loaded. We ended up creating some sessions and people can get together and talk and discuss on different areas. Wolfgang, anything you want to add?
Maybe just from the program perspective, there are sessions on advanced modeling languages, but we also have applications of conceptual modeling and language models and conceptual modeling. You see the importance of AI, a lot about ontological modeling and process modeling. So these are the current big topics that we are addressing. And the overall theme of the conference, conceptual modeling, AI and beyond, might indicate a little bit what you might expect if you would join.
Yeah, I would like to give a full name because nobody gives a full name. So it's the 43rd International Conference on Conceptual Modeling. And then the main theme is like Wolfgang says, conceptual modeling, AI and beyond. So people come and meet diverse people that will give a lot of diverse ideas. Yeah, I invite people.
Yeah.
Great, thank you for that. All right, we got lots more questions in the queue here. So we're down to about 7 or 8 minutes. So we'll work in as many as we can here. Hasan, we're going to go back to you with one from Adele asking, what notations, languages, methods, and frameworks are worthy of learning and trying, particularly for software-intensive systems? What do you got?
So I'm going to start a common vocabulary that we use all the time in software engineering. I'll say it depends.
Yeah.
maybe not the right answer. You might be looking for it, but actually it really depends. It truly depends what you're trying to achieve. So there are known notations. So notation is basically describing how you're going to visualize those abstractions and construction phases. So there are known notations as accepted in the community, like a Chen notations and other notations as well in UML. As long as we have a clear understanding what things we are trying to build it, what we're trying to visualize it, clear understanding means represented. One typical I use in my class as well as the drawing, I always say is if you put any graphics, any visualization, put the legends in it. Explain what the triangle means, what the arrow means. Explain those as the legends that you use. Give me some indicators that I can understand what you're trying to present it. So as long as your graphics has some legends and notations in it, I think it's basically achieved the job. Remember, we are trying to create a shareable knowledge. We are trying to create some visual representation that has self-explanatory in it. We don't need another person to explain what it is. When I look at the graphic, I should be able to understand what this product we are trying to build it. So as long as we are able to keep that component with the legends, that should achieve the job. It can be a PowerPoint represent, it may be a Visio, it may be a graph, as long as there is a context in it that explains what you mean about your arrows or the triangles or the rectangles, whatever the shape that you have. Give me an explanation, give me some kind of how to read guidance documents as your notation, and I can take it and use it.
Yeah, maybe from a practical perspective and the project that I work on, I can only emphasize what Hasan said, that having a shared toolbox of languages that you can actually use. And if you look at some of the suites that support UML, there is too much in it. So you have to select what are the notations and the artifacts that you really want to look at that is helpful. This is an essential task. And then if you agree on that, this is already a big achievement. And then, I mean, from a more practical point of view, in practice, you're using a lot of UML class diagrams and sequence diagrams, activity diagrams. But if you go into process modeling, BPMN is most likely one of the key languages that you are using. but this is only, let's say, a top level selection. Yeah, it depends on your task, but then you need to agree on it.
Can I go back once more? This is maybe you don't touch it, maybe kind of skim through it. We need to get the people to work together, build up those models. It is not a one person build everything. It's requiring a collection of people who are in that domain. It's not we're going to say, hey, go figure it out and get back to me a diagram set about the system. No, it is requiring a communication. It is requiring understanding. And like it's 101. If I start writing any solution of any domain, I have to be like an accountant in that domain to understand what that means. Sometimes I have to understand what the business is trying to do so I can be kind of knowledgeable enough to talk about. This is not going to happen by working siloed. It is requiring the coordination with related stakeholders to describe the concept and abstraction of the business. We don't want to say just do by yourself. Work with the team, work with people, so we have common understanding. Like always say, you're sharing with something that I don't what. How can I understand? What can I do? I'm just going to do whatever I want. But we're looking for more communications, more explaining. Like we may be speaking same language, but we may not able to speak same language in the context of software engineering. Let's try to speak the same language in the context of engineering. That's what the modeling is going to help to speak the same language between architects, developers, or business. We are in the same page about the product we are trying to build it.
Great, thank you for that, Hasan. So let's wrap up with this. I'm going to give you each about a minute. Jay had asked a question: why do you think entity relationship modeling is the best choice for your approach? So if you each can touch on that, maybe. Also, we had a good question from Mark John in the chat earlier, asking for you guys just to recommend any textbooks or approaches that you guys would, or books that you could maybe recommend for our audience, and then just any closing thoughts. So we'll start with you, Hasan. Why is entity relationship the best modeling, best approach? Book you recommend, and any closing thoughts, and then we'll go to Wolfgang.
Well, I will start with the why into the relationship one. So I will say, definitely, if you're able to represent in the construction phase of that business model, you create it and try to visualize it and create a relationship between each others. You may say, I'm using maybe a NoSQL type of database. Still, there is a relationship of the business. It doesn't mean you're going to create a database schema. So there is kind of a misconception. Sometimes you always say, I'm going to create entity relationship, always business. May not be a business related, it's a databases. Let's think about the business relationship. How can I translate that business relationship as an entity that goes back to the construction? It can be a relational database. It can be a NoSQL kind of a unstructured database, but it goes back to the business concept we are trying to. So define your entities, what entities are in the business context. Let's think about entity can be an invoice or something else. And then think about the representation of data in the database and the process layer. So I'm going to stop here and maybe go to Wolfgang because enough time, and Wolfgang or Hyoil can share some.
Go ahead.
I make it very quick. So the advantage, I mean, there are other languages you can use, but ER has a clear visualization of a relationship between entities. I mean, that's in essence. It's flexible. It can be modularized. It has strong support by very many tools. It has a certain kind of simplicity that you can use in quite various areas, and it is scalable so that you can grow the model as the system also grows.
We're not going to let you off without your book, Wolfgang. Any book you can recommend?
Books is they are a little bit outdated. I would recommend to come to the conference and to listen into
Great
the
very well said. You said come and meet the author, right?
There
yes. There you get the essence.
Yeah,
all yours.
Yeah, to me, it's ER is very easy to understand, and you can express all the entities and relationships with the constraint, everything. Even though complex system, you can express using ER, and you can modularize the system. So, and then I recommend one book. It's an easy book, but it's very complete. It's a Fundamentals of Database Systems. It's by Ramez El-Majri and Sham Nabate. And it's a very easy to understand. You can read alone and you can understand ER very well. Very well done. Yeah, that's it.
Awesome. Hasan, Wolfgang, Hyoil, great discussion today. Thank you so much for sharing your expertise. And again, we thank you all for attending today. Upon exiting, please hit the like button below and share the archive if you found value. As we stated, we do invite you to attend the 43rd International Conference on Conceptual Modeling, October 28th through 31st in Pittsburgh, Pennsylvania. Details are available in the chat area now, and we'll email out some information to registrants as well. Also, you can subscribe to our YouTube channel by clicking on the SEI seal in the lower right corner of your video window. Lastly, we also invite you for our next webcast, which will be October 23rd, and our topic will be independent verification and validation for agile projects with Justin Smith. Registration information is on our website now and will be emailed out as well. Any questions from today's event, please send to info@sei.cmu.edu. Thanks, everyone, and have a great day.
Thank you.